Okay, good morning. So today we will discuss few more the examples which comes under prism. So till last class we have discussed the different prisms resting on edges as well as the corner. And today's class, one example we'll discuss the freely suspended type. The same freely suspended, the special case we have discussed in pyramids also. The same concepts holds good here also. So let us discuss the square prism. So the same procedure holds good for the pentagon as well as the hexagon prism. So one I have taken the example. The question goes like this: a square prism 35 millimeters, the side of base and the axis height is 60 millimeter, is suspended freely from one of its corners of the base. Draw the projection of the prism when the axis appears to be inclined to VP at 45 degree. That means, so this you have to make it clear. The freely suspended is always we have to suspend it freely from the corner only. From the corner only we have to suspend it. From the edge we cannot suspend it. For example, this is a prism. So the base corner means from this corner only I can able to suspend it. I can hang it freely like this. So that's why. So any freely suspended from the base corner in the sense. So we have to consider the corner condition only for the initial position or the true shape diagram. Since it is so resting on HP, so what you can do? It's a square prism of 35 millimeter. You draw this top view such that the corner should come right side of you. That is, it's a corner condition because the corner only I can able to suspend it freely from the corner. That too is given the base corner, right? So that's why you draw a square of 35 millimeter, the top view, such that any one of the corners should come right side of you. And after this, how to draw a corner condition in a square? So take any one point, draw horizontal line. From that point, draw 45 degree line above and below that point, below and above the horizontal line. Then you take 35 millimeter. So this is the center you cut. This is the center you cut the 45 degree line. Then from here you cut this horizontal line, and from here you cut this horizontal line. The 4 points will going to get joined. So you're going to get a perfect the square of 35 millimeter. So after constructing a square, the four corners are there. The base as well as the top face corners, you can name it in whichever the fashion you want. And to locate the center, draw a light diagonal and locate the base center as well as the top face center. And those lines should not be visible. Okay, that's why I'm not shown here. Only for the pyramids in the top view true shape diagram, the center of the any polygon should be joined to the corner. But whereas in the prism, just to locate the center, we need to draw the diagonal. Later you have to erase it. Okay, so this completes your the top view because the freely suspended from one of its corner of the base. That's why the corner condition we have to draw. This completes your top view. To get the front view, you keep on draw the vertical projectors from all the points like this till it meets the XY line. So what is the axis height is given? The axis height is given is 60 millimeter. Above XY line, you take axis line, draw an horizontal projector line. Now you extend all this lines and wherever it meets the 60 millimeter horizontal line, so join those lines with the visible edge and complete this square. So it complete this rectangle. So in the front view, it look like a rectangle square prism. See, this is the corner condition. The corner you have written the right side of you like this. You will you can see in the top view. The front view you can see here. So the axis point you cannot see. One of this longer edge will look like a visible edge. So it look like a rectangle. So the rectangle I have written here. So and you are looking from here A, B, C. I can see. I cannot see D. So that's why the point D within the bracket I should write. Similarly, A1, B1, C1 I can see. I cannot see D1. That's why. So D1 should be written within the bracket. and the rest of the things remain same. And after completion of this your front view, okay, so how we have located the center of gravity in the pyramid? Can you remember that? For the pyramid, so how you have located the center of gravity? The center of gravity for any pyramid, it lies 1/4 of the height from the base, that the axis line. So that is the center of gravity. So whereas a prism is a uniform cross section you will get from the base to the top. Correct. So that's why, so center of gravity of the any prism, once again I'll repeat it, the center of gravity of the any prism lies exactly at the center of the axis point. That is half of the axis height, exactly at the center of the axis line, the center of gravity is located. How to find out the center of gravity? Which is the center line? So this is the axis line, but here I cannot represent the axis line. Why? Because already the visible edge is there. This longer edge, okay, will coincide within the axis line. So that's why this is the axis line. And what is the total height of the prism? It is 60 millimeter. Half of that, how much? 30 millimeter. So above XY line you draw, you take 30 millimeter above XY line, draw on horizontal. Wherever it meets this axis line, so that is your center of gravity, which I have marked it as a G dash. Once again, I'll repeat, for the prism, so center of gravity lies in the axis line only, exactly at the midpoint of the axis. That is half of the height of your axis line. So that is the center of gravity for your any prism. So I have taken the half of the 60 means 30 millimeter. I have taken and drawn a horizontal line, and this is the axis line. So here I have located the center of gravity, that is G dash. So how we have done in the pyramid? So the corner where exactly we are suspending it, we are joining that corner to your center of gravity, right? The rest of the procedure remains same. Only to locate the center of gravity, the prism and pyramid are different, whereas the rest of the procedures remain same. So you have taken the right corner as the A1 dash. So A1 dash, I will going to freely suspend it. That is the corner of the base where, so I will be suspending the sphere prism. That's why you join the center of gravity point to the corner where you are suspending, that is A1 dash, with a light line. This is the construction work that you have to do before proceeding to the next position, front view. Okay, after drawing your front view, you have to locate this center of gravity point. From that point, you have to join it to the corner on which you are suspending it. That is A1 dash is my corner which I have taken right side of me. So I have joined it. This should be a light line. This is a construction line. So this completes the initial position or true shape diagram. After this, I need to suspend it freely. Correct. So next turn. So you take any point on the right side. Any point on the right side, and call that as the A1 dash point, because that is the corner which I will going to suspend it. Got it? So I call that as the A1 dash, and then draw a vertical line. So here I have not shown here, I have depicted here. You draw a vertical line from the A1 dash, and it should be perpendicular to XY line. Okay, so what you have to do, you have to take any one of the point right side, some height you have to take, so that it should not cross the or touch the XY line like that. Approximately, you call that point as the corner A1 dash. Now I'll draw a vertical line from A1 some length, and it should be perpendicular to your XY line. Now I'll take A1 dash to G dash distance. I'll take A1 dash to G dash distance. From A1, I'll cut this vertical line or perpendicular line to XY line, and I'll call that point as the G dash. So A1 dash G dash line have located. Okay. So after locating this A1 dash and G dash, so you have to redraw this rectangle such that this A1 dash G dash should coincide with the constructed line A1 dash and G dash. How to draw this? All of you know. First, you have to take any one of the point that you call it as the A1 dash, this corner. Now you draw a vertical line, a perpendicular line to XY line. After this, you take A1 dash to G dash distance. A1 dash is the center, you cut this vertical line, you call that as the G dash. So I got this A1 G dash distance. Okay. Now I have to redraw the entire rectangle. How to redraw it? See here, from A1 dash to C1 dash distance you take and cut an arc. Okay. Next, G1 dash to C1 dash distance you take, you cut an arc. So wherever these two are coincides or intersects, so you can call that as the C1 dash. So once you get the C1 dash, you join A1 dash and C1 dash. Like this line you can draw. Okay. And this is the base and this is the face. Correct. This is the base point you got. How to get this point? You draw a vertical projector at a perpendicular line. So from A1 dash you draw a perpendicular or vertical line from here, a perpendicular line to this line. C1 dash also you draw a perpendicular line or 90-degree line, some length. After that, so what is the height of this prism? This is 60. So from C1 dash you cut this perpendicular line by 60 millimeter. Same distance from A1 dash you cut this the perpendicular line with 60 millimeter length and call this as the A1 A dash and C dash. Now you join this A dash and C dash. And A1 dash A you can join, C1 dash to C you can join. How to get this particular point? You know A dash and C dash you know, as well as A1 dash, C1 dash you know. You take A1 dash to this distance, mark it here and transfer all the corresponding points. Same thing from here, you draw a perpendicular line, and see to that, okay, it has to pass through on this G point. It has to pass through on G point. Then only you have drawn properly. And till it meets this line, you stop it and transfer this corresponding points also. This how you have to redraw your previous front view such that this A1 dash G dash of this rectangle should coincide on this A1 dash and G dash. Like this, any method you can use it. Only thing is, so this construction line is very, very important. Drawing perpendicular line and taking this A dash A1 dash G dash distance, and then whichever the fashion you want, you can redraw it. So like this, you have to redraw it. So this completes the front view. Next, how to draw the top view for this? The top view, as usual, to keep on draw the vertical projectors from all these points like this one by one, and draw the horizontal projectors also like this from the previous top view. Coincide the points. So A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here, C dash is here, this is C. D is here, D dash is here, this is D. A1 is here, A1 dash is here, this is A1. B1 is here, B1 dash is here, this is B1. C1 is here, C1 dash is here, this is C1. D1 is here, D1 dash is here, this is D1. O1 is here, O1 dash is here, this is O1. Like this, all the points you have located. Now you have to see from the top. So you are looking from here, the complete this face you can see. That is base point, which is that A1, B1, C1, D1 you can see, which is that. So A1, B1, C1, D1 you can mark it as the visible edge. And coming to this particular portion, you are looking from here, A to B, A to D you can see, A to B, A to D, and it becomes outermost boundary line or outline of this the prism, and almost it look like a corner condition line. So what is the hint which I have given for the corner condition? What are all the edges which are coming out from that corner you cannot see. So from this corner, the base edge, BC and CD you cannot see. CD and BC you cannot see. That you should highlight with the hidden edges. Now coming to the longer edges, you are looking from here. A1 to A you can see. A1 to A. B1 to B, D1 to D, you can see it becomes outermost boundary line. And you are looking from here, what about this C1 to C? Can you see that? No, you cannot see. C1 to C, you are looking from here, you are looking from top view. That is front, that is from the top side you are looking. C1 to C you cannot see. That's why C1 to C you can make it as a hidden edges. Axis line it is there from O1 to O, but already the visible edge is here and hidden edge is there. I cannot represent the axis line, but axis line is present. So this completes your the second position, top view. Next, after this, coming to the third position, so himself has given the axis appears to be inclined at 45-degree line. So no need to take the locus. That means he has given the parent inclination itself. That is, he has given the beta angle. So that's why you take any direction, whichever the direction you want, you can draw 45-degree line. After drawing 45-degree line, so what you have to do? You have to redraw this the parent shape of the prism such that this axis point O1 to O should rest or lies on this 45-degree line without changing its shape and size. So how to do it? I'll take any one point and I'll call that as the O1 axis point. Now I'll take this O1 to O distance. From this O1 I'll cut it here on this 45-degree line. So O1 got. Okay, how to get the rest of the points? From O1, C1 and A1 distance is same. You cut it on the same 45-degree line, you're going to get similarly from O to A, O to A1, O to C distance is same. O to A, O to C distance. So you can get those 2 points also. And to get this point from O1, you draw a perpendicular line to this 45-degree line like this, which are not shown here. After drawing 90-degree to 45-degree line passing through this O1 as well as O, you draw a 90-degree line to 45-degree line. Now O1 to D1, O1 to B1, O to D, O to B distances, all the 4 distances are same. So from this O1, you can cut on either side of this perpendicular line. From O, you can cut on either side of this your O, that is perpendicular line. So now you're going to get all the points. Now without changing its shape and size, including the visible edge and hidden edges, you redraw it here. So this completes your the final position top view. Now to draw the front view, keep on draw the vertical projectors from all these points, from all the points, and draw the horizontal projectors also from all the points like this. Coincide the points. How to do it? A is here, A dash is here, this is A dash. B is here, B dash is here, this is B dash. C is here, C dash is here, this is C dash. D is here, D dash is here, this is D dash. O is here, O dash is here, this is O dash. Similarly, A1 is here, A1 is here, A1 dash is here, this is A1. B1 is here, B1 dash is here, this is B1. C1 is here, C1 dash is here, this is C1. D1 is here, D1 dash is here, this is D1 dash. And O1 is here, O1 dash, this is your O1 dash. Like this, all the points located. So after this, so you are looking from here. This is front view, correct? So you are looking from here. If you are looking from here, the complete this the base you can see, which is this A B C D you can see with the visible edge. That's why A B C D is visible. Okay, so almost this exercise, okay, very much similar to your the square prism corner condition example. Okay, this complete base you can see. Coming to this, so you are looking from here, C1 to B1 you can see it becomes outermost boundary line, as well as A1 to D1 also you can see it also becomes outermost boundary line. Whereas you are looking from here, D1 to C1, D1 to C1 you cannot see. C1 to D1, D1 to A1 you cannot see. So that's why these two edges are the hidden edges. Once again I'll repeat, see, you are looking from here, A1, B1 you can see, A1, B1 and C1, B1 also it looks, we cannot see here, you are looking from here, C1, B1, but it becomes outermost boundary line. For this outermost boundary line I cannot show the dotted line, correct? And similarly we are looking from here, C1 to D1, D1 to A1 to D1, D1 to C1 you cannot see these two edges. And coming to the longer edges, you are looking from here B to B1, you can see as A to A1C, outermost boundary line. C to C1, you can see it also becomes outermost boundary line. And you are looking from here D to D1, can you see? No, you cannot see that. D dash to D1 dash, it is hidden edge. And as usual, axis line from O1 dash to O dash, you have to locate it like this. Only thing is here, it is almost similar to the corner condition square prism. Here, it is freely suspended from the brace corner as given. So initial position you have to take the corner condition only, and only the construction work that you have to do is to locate the center of gravity off of the axis height. In the axis line only you have to locate the center of gravity. That is the only thing in this. Okay, so the same procedure holds good for your pentagon prism as well as the hexagon prism. You can try it out. Okay, so this completes all the prism, and even cube we have not discussed. So that also we're going to discuss. Okay, cube. So cube also comes under your square prism only. Cube is also a square prism. When your the square prism will become cube, when the axis height also equal to the base edge of your square prism, it becomes the cube. See, this is a cube, and it is also called as a hexahedron. The hexahedron and cube one and the same. What do you mean by hexa? 6. Hexahedron, that means a cube will be having 6 similar square faces. That's why it is called as the hexahedron. How many 6 similar square faces? 1, 2, base and top face. 1, 2, 3, 4. The boundary faces, the 4 faces which is bounded like this. So that's why how many the similar faces it has got? 6 similar faces, top face, bottom face, and side faces 4. 1, 2, 3, 4. That's why it is called as the hexahedron, means it has got 6 similar square faces, and it is also called as a cube. What he has given? A hexahedron are nothing but a cube of 40 millimeter. The cube 40 millimeter means the base, all the 4 sides of the base is equal as well as the height is also same. So if the height is also same as that of the base, then a square prism will become cube. It says hexahedron of 40 millimeter, the side of base rests on edge, one of his edge which is inclined to VP at 30 degree. Draw the projection when the lateral square face containing the edge which it rests makes an angle 50 degree with respect to HP as given. So first, so he has clearly given it is resting on one of his base edge. So that's why, so you draw the true shape diagram such that any one of the edge should come right side of you. That means a cube in the top view, it look like a square only. Okay, so the top view you draw a square of 40 millimeters such that the edge should come right side. That's the edge condition you draw it. Okay, and name the 4 corners whichever the fashion you want. The top 4 corners and bottom 4 corners you can name it, and draw a light diagonals to locate the center. Afterwards you can erase this diagonals. Okay, so we cannot see the edges. Okay, just to locate the center we have to draw this diagonal. Locate the axis point also, O1 and O. So this completes the top view. To draw the front view, the cube, the specialty of your cube, the top view also it look like a square, and in the front view also it look like a square only. Whereas in the okay, welcome back. So in between it is disconnected. So I'll start once again. So the front view also it look like a square only. So this is the thing. So how to draw it? You draw the vertical projectors from all the points like this till it meets the XY line. Now the height is also same for the cube or the hexahedron. 40 millimeter you take, you draw a horizontal projector line. Now you project it till it meets 40 millimeter line and construct a square. Axis line as usual you can show it here. Okay, and coming to the points, you are looking from here. A, B you can see, you cannot see C and D. C dash and D dash you cannot see. Similarly, A1, B1 you can see, you cannot see C1 and D1. That's why C1 dash, D1 dash should be written within the bracket. Okay. So after this, the next, the one which he has given for the next position, he has not given the axis inclination, he has not given. So what he has given, the lateral square face containing the edge which it rests makes an angle of 50 degree with respect to HP as given. So this is the cube, correct? So this is the cube and which is resting on this, the edge, correct? The lateral, the face which is resting on this edge is nothing but this face I have to consider. This is the lateral face. So this is the base of the cube. This is the face of the cube. These are all the lateral face. Okay. So that means, so when it is tilted like this, in the sense the lateral face, this is the lateral face containing the edge. So it is the edge condition you have written. The right side you have taken the edge on your and then the top view and front you have written. And then after this, the lateral face containing the edge. This is the edge where you are taking it. This is the lateral face containing this edge. So like this you have to tilt such that this lateral edge is making an angle of the 50 degree with respect to HP. With this, how to draw it? So you take any one of the point and draw a 50 degree line and draw a 50 degree line right side like this. After this, so you call this point as the A1 dash and D1 dash and you have to draw the 50 degree line, correct? So this is the lateral face actually. So this A1 dash, A dash, D dash and D1 dash is the lateral face. So that means you have to redraw the square such that this lateral face, that is this particular, the line should lie on this 50 degree line, like that you have to redraw it. How to draw it? How to redraw this? So this point you have transferred here and this 50 degree line and then take this length, that is 50 millimeter, 40 millimeter. This is the center you cut 50 degree line, that's all. So transfer this particular points also. How to construct the square after getting these two? From here you draw 90 degree line and from here you draw a perpendicular 90 degree line. Okay, and this distance is also 40 millimeter. Since it is a square, from here you take 40 millimeter and cut this perpendicular line. From here you take 40 millimeter, cut this. After this, you join these two lines as well as these two points and transfer all these points here without changing anything. That means you have to redraw the square such that the lateral face containing this edge, it is resting on A1 dash and D1 dash. This is the edge which is resting. The lateral face containing this edge is this A1 dash, A dash, D dash and D1 dash. That's why we have to incline that face which is inclined to 50 degree with respect to HP, like that. Like this you have to redraw this. Okay. The next position, it is similar to the square. It's almost a cube. This example is similar to the square prism resting on the edge. So keep on draw the vertical projectors from all these points and draw the horizontal projectors also like this. After this, coincide the points. A is here. Where is A? A is here. A dash is here. This is A. B is here. B dash is here. This is B. C is here. C dash is here. This is C. D is here. D dash is here. This is D. And O is here. O dash is here. This is O. Similarly, A1 is here. A1 dash is here. This is A1. B1 is here. B1 dash is here. This is B1. C1 is here. C1 dash is here. This is C1. D1 is here. D1 dash is here. This is D1. O1 is here. O1 dash is here. This is O1. Like this, all the points you are getting it. Now you are looking from top. If you are looking from this direction, the complete this face you can see, which is that ABCD. So immediately you make it ABCD a visible edge. That's all. And coming to the, you are looking from here, D1 to C1 you can see it becomes outermost boundary line. And C1 to D1, B1 to A also you can see, B1 to A1, C1 to C, because it becomes the the boundary line also, as well as outermost boundary line. And what about the edge A1 D1 which is resting on HP? That you cannot see. That is the only edge that you cannot see, A1 D1. So that should be a hidden edge. And coming to the longer edges, D1B, C1C, C1C, B1B. So it becomes outermost boundary line. I cannot draw the hidden edge over there. And similarly, even these two we cannot say actually. A1 to A1 to A, D1 to do. I cannot see actually. See, A1 to A and D1 to D. But I cannot show the hidden edges over here because it becomes the outermost boundary line. And axis line as usual I can represent it like this. So this how you have to complete the cube like this. The second position. Coming to the last position, he has given so the base edge which is resting on HP making an angle of 30 degree to VP as given. Correct? Which is the base edge which is resting on the HP A1 D1. So A1 D1 edge you should tilt it such that it is inclined at 30 degree to VP. Either like this 30 degree line you can draw, or else like this you can draw the 30 degree line. I have taken the 30 degree line like this. So I should redraw this the previous top. You said that this D1 A1 should come on this 30 degree line. That's all. So after drawing 30 degree line, so I'll take any one of the point on this 30 degree line. I'll call it as the D1. After calling it as the D1, I'll take this D1 to A1 distance. D1 to A1 distance. I'll cut it. Okay. D1 A1. I'll be getting it. So after this, what I'll do? I'll draw a perpendicular line from D1 on both the sides to this 30 degree line, as well as from A1 also I'll draw a perpendicular line on both the sides. After drawing perpendicular line, D1 to D and A1 to A distance is same. So I'll cut this perpendicular line. Similarly, C1 to C and B to B1 distance is same. We cut on the other side of the perpendicular line. So you'll be getting all the points. How to get these axis points here? The axis points. So C2D or D1 to A1. You take the center, that is midpoint, center, because total it is 40, right? Axis point exactly at the midpoint you are going to get, correct? So you take 20 millimeter from this D1 or A1 and just locate one point, because total this is 40. Half of that where exactly the axis lies, it is 20 millimeter. Half of that you take, that is 20 millimeter, cut on this point. After getting this point, here you draw a perpendicular line on either side like this to this 30 degree line, perpendicular line. So from here you take O distance, cut it on that perpendicular line, call it as O, and from this line to O1 you take the distance and cut it here and call it as O1. Like this you have to redraw it. So what you have done here, without changing anything, the shape and size, this D1 and A1, the edge which is resting on HP should be inclined to 30 degree to VP. That is, you have to redraw it on the 30 degree line. Like that you have to redraw it. This completes the top view. How to get the front view for this? Keep on draw the vertical projectors from all the points like this, and draw the horizontal projectors also from all the points like this. Now intersect the points. So A is here, here is A dash is here, this is A dash, B is here, B dash is here, this is B dash, C is here, C dash is here, this is C dash, D is here, D dash is here, this is D dash, O is here, O dash is here, this is O dash. Similarly, A1 is here, A1 dash is here, this is A1 dash, B1 is here and B1 dash is here, this is B1 dash, C1 is here, C1 dash is here, this is C1 dash, and D1 is here and D1 dash is here, this is D1 dash. O1 is here, O1 dash is here, this is O1 dash. After getting all the points, you're looking from here. You're looking from here in the sense, the complete this face for the front view, you're looking from here, the complete this face you can see, which is that A1, B1, C1, D1. Immediately you make this A1, A1, B1, C1, D1, the points as the visible edge. And coming to this face, you are looking from here, A1 to B1 you can see. So this one. And A1 to D1 also you can see. Correct? So A1 to A to B. A to B you can see. Here is A to B you can see. As well as B to C also you can see. And C to D, D to A you cannot see. C to D, D to A you cannot see. These two edges which is behind you. You are looking from here. B to A, B to C you can see. You cannot see C to D and D to A. Those two are hidden edges. Coming to the other edges, you are looking from here. B1 to B. You can see outermost boundary line. A1 to A also you can see outermost boundary line. And C1 to C, outermost boundary line you can see, but we are looking from here, D1 to D you cannot see, D1 to D, that should be hidden edge. And as usual, axis point you can locate from here to here. So this of the cube, okay, it's done almost, it is similar to your square prism edge condition only. And even the cube corner condition is given, only thing is corner condition you have to take, and whatever the information he has given you have to complete it. So with this, all the examples of the prism also we have completed.